All right, guys, in this lesson, we're going to be looking at a chi-squared test for independence. And our objective here is just to run a chi-squared test for independence of two categorical variables. So before we get going, last time we looked at a chi-squared test for homogeneity. Okay, and the chi-squared test for independence is almost identical with the exception of kind of the end goal of what you are actually trying to test for, what you're trying to hypothesize. So again, the definition for a chi-squared test for homogeneity is a hypothesis to test to determine if the distribution of categorical variable is the same for several populations or treatments. So you're kind of trying to see if one categorical variable is the same for all populations or for several populations. A chi-squared test for independence is really only testing one of those things. So it's a hypothesis test to determine if there is an association between a row and a column variable in a two-way table. And we'll kind of show you an example of what they're looking for to kind of give you a distinguishing factor between the two tests. So a study followed a random sample of 8,474 people with normal blood pressure for about 4 years. All individuals were free of heart disease at the beginning of the study. Each person took the Spielberger Trait Anger Scale test, which measures how prone a person is to sudden anger. Researchers also recorded whether each individual developed coronary heart disease, or CHD. This includes people who had heart attacks and those who needed medical treatment for heart disease. And here's the two-way table that summarizes the data. So again, when we're running a chi-squared test for either homogeneity or independence, they're both going to use a two-way table. Okay, and you'll notice that each one of the columns represents the anger level. So this represents low anger, moderate anger, and high anger levels. And then whether or not they had the actual heart disease itself. So CHD represents that they did have a heart disease. No CHD represents that they did not have a heart disease. Okay, and so Part A asks us to define whether this is an observational study or an experiment and justify our answer. So this is what's known as an observational study. There was no treatment imposed on the individuals, so it can't be listed as an experiment. And then if we want to see the graph below to justify our answer, there appears to be a relationship between anger level and heart disease. As the anger level rises, the percent with CHD also rises. So that's answering for Part B. We want to make a well-labeled bar graph that compares CHD rates for the different anger levels, and then we want to describe what we see. So before we get into actually running that test, we need to remember that it's as always, you have to state the 4 parts. So the first part is just the state part. We want to state the hypotheses as well as the parameter. And when we're stating hypotheses, we want to say that the null is that there is no association between the two variables, whereas the alternate is that there is an association between the two variables. So that's kind of the difference between running a chi-squared test for independence and homogeneity, is that when you're looking at independence, you are saying that there is no association between whatever two variables you're testing, or there is an association. So association is kind of the key word here when you're looking at independence. Then from there, you want to check conditions. So we want to check to see if it's random. The samples must come from a well-designed random survey or experiment. They must be independent. If it's a survey, the sample size should be more than 10% of the total population. And then we also want to check that large counts condition or expected counts condition, which is that the expected counts of any category cannot be less than 5. And again, how you find expected counts with a two-way table is you take the row total times the column total divided by the table total. So we would have to take the row total times the column total divided by the table total in order to determine what the expected count is for a low anger patient that did have a heart disease count right here. Okay, so that's how we would find that expected count right there. Then from there, if we want to run in order to find our test statistic, or the do portion for this chi-squared test, is the distance observed values are from the expected counts. So again, we're looking at epsilon of the observed count minus the expected count squared divided by the expected count plus the next instance of that, so on and so forth. Our degrees of freedom is another test statistic that we need to find, and that's total categories minus 2. So we want to take our row -1 times our column -1, and that's going to give us our degrees of freedom. And then from there, we need to conclude or perform the last step. And so we need to make a decision about the null hypothesis, whether to reject it or to fail to reject it. And then we need to give evidence for or against the alternate hypothesis in our conclusion. So when we are looking at the same example, if we were going to run this test, we would be asked, is there a significant association being the key word there, and that tells you whether or not we're looking at independence or not. Is there a significant association between anger and heart disease at the 5% level? So when you have a significance level of 5%. So again, if we were to try to just find our test statistics right off the bat, and actually I'm going to come back to that. Let's go ahead and just work through this in order. So again, our state portion right here is going to be stating the populations as well as the hypotheses. So the parameter is the association between how prone people are with normal blood pressure, how prone they are to sudden anger, and their development of CHD. Our null hypothesis would be to say that there's no association between anger and the development of a heart disease, whereas our alternate hypothesis is that there is an association between anger and the development of heart disease. All right, from there we would plan or complete our plan portion, which is that we're told that the sample is random. It's safe to assume that 8,474, which is our total number right here, is less than 10% of all people with normal blood pressure, and all expected counts would be greater than 5 based off of our data right here. Okay. From there, we would want to run our chi-squared test for independence and find our test statistics. So our chi-squared statistic, again, you can go to second matrix, which again is that button that is right to the left of sign on your calculator, then arrow over to edit and select matrix A. Okay, and then from there you would enter in, you know that this is supposed to be a 2-row by 3-column matrix right here, and you can just enter in all of the values that they give you in the table right there. And be sure, do not include the total values when you're entering in when you're entering in that data into the matrix. Okay, and so once you've done that, then you can go to stat, arrow over to, stat, arrow over to tests, and then go down and find C, or wherever that chi-squared test is. Make sure that matrix A is entered in for the observed, matrix B is entered in for the expected, and from there hit calculate or draw if you're wanting to draw your graph. But calculate is going to give you your chi-squared statistic of 16.076 or 0.77 with a p-value of 3.22. Not 3.22. And that's to the 10th times 10 to the -4th power. So it's going to be 0.000322 with your degrees of freedom at 2. Okay, and then if you needed to know the expected counts for whatever reason, you can always go back to second matrix and then arrow over to edit and look at matrix B, and you should see all of the expected counts once you've actually run that test. But again, this is the do portion of our problem right here. So once we found all of that information, we know that our p-value is this. From there, we can create our conclusion, which we know that our p-value is going to be less than 0.05. So in that case, since it's less than the significance level, we would reject the null, and we would say that there's sufficient evidence to believe that there is an association between the onset of sudden anger and the development of CHD. So again, when we're finishing out, or when we're giving context to our conclusion, you want to make sure that you are using the alternate hypothesis. So in this case, there's sufficient evidence to believe that there is an association, or there is not sufficient evidence to believe that there is an association between the onset of sudden anger if we were to reject the null as well. So again, make sure that you conclude as well as give context to your conclusion, basically. And then finally, just using chi-squared wisely, again, both the chi-squared test for homogeneity and the chi-squared test for independence start with a two-way table of observed counts. They even calculate the test statistic, degrees of freedom, and p-value in the same way. So, very much the same kind of problem that you're going to be solving in this case. However, the questions that these two tests answer are different. A chi-squared test for homogeneity tests whether the distribution of a categorical variable is the same for several populations or treatments, whereas the chi-squared test for independence tests whether two categorical variables are associated in some population of the interest. So this can be kind of a confusing concept to differentiate between. The goal here that you really understand and that you at least get is that is how you do a chi-squared test, which is very similar to every other test that we've done, significance test, test for differences, all of those things that we've done, confidence interval, all that. You perform the test in almost the same way. But if you are having trouble differentiating between what a test for homogeneity is or an independence test, if you have trouble distinguishing those two types of chi-squared tests for two-way tables, you're better off just saying that we are going to run a chi-squared test as opposed to a chi-squared test for homogeneity or independence. Than just stating the wrong type. So if you don't know which one to run when you're actually stating in the problem that we are going to run a chi-squared test for independence, just say that you're running a chi-squared test because it's going to be better than saying the wrong one. Okay. So yeah, that's pretty much it.